Okay, now let's look a little bit closer at resource allocation methods, time constrained and resource constrained. So let's look at some limiting assumptions. First, splitting of activities is not allowed. What does that mean? I can't start an activity, stop it, send somebody somewhere else, come back, start the activity, maybe stop it, come back. Once we start an activity, we're going to complete it all the way. Now, we'll talk a little bit about more of this later, but for our initial, let's assume we're not going to split anything. And we're going to assume the level of resources used for an activity cannot be changed. So what do we mean by that? So if you thought that this was a two-person activity, not halfway through you're going to throw 3 or 4 people on it. Again, we'll talk a little bit about what happens if you get into trouble later on, but in Chapter 9. But right now, let's assume you said this was a two-person job. You're keeping 2 people on it. Risk assumptions: activities with the most slack pose the least risk. So in other words, if some project has slack, okay, it's the least risk to me because it can move around a little bit and it's not going to cause me a problem. Okay, so another way of saying this is activities with no slack on the critical path, those are high risk. I don't want to mess with them. They say they need 2 bodies, I'm putting 2 bodies. Okay. The reduction of flexibility does not increase risk. So by me moving tasks around, as long as there was slack, and if I move them around, I'm not increasing my risk. Well, we're going to assume that for now, but that's not really always true. If I start eating up some of my slack, I might be getting into a little bit more risk, but we're going to manage through that right now. And we're not going to look at whether an activity is easy or complex or whatever right now. Again, later on, you might do that. If you had 2 choices and one was harder than another, you may delay the easier one because you figure, I'm not going to take a chance and delay the harder one. Right now, we're just going to delay them, assuming they're all basically the same level of complexity. Again, not always true, but that just adds to the problem. But first, let's go through some of the simpler methods. Okay, so time constraint must be completed by an imposed date. That's what we talked about. Talks about require leveling of techniques that we can balance our resources, and we're going to use our slack to balance our resources. Okay, so let's look at an example. Remember, I talked about resources as being people, humans, yes, but it can also be equipment resources, okay? And that's actually a little easier to look at. So let's look at this example here for a botanical garden. So you need BHs, which stands for backhoes, okay? You need some backhoes. And you need 2 backhoes for the first part, then you need another backhoe for the walkway, irrigation, 2 more for here, then you go down to 1, and then you go down to 3. So look at this. I need 2 backhoes, 4, 1, and 3. Well, and if you're the project manager, you say, that's great, that's what I need. I'm the functional manager and say, I can't give you 2 and 4 and 1 and 3. I want to balance this out a little bit better so I can balance resources and use them somewhere else. So here it is plotted out, 2, 4, 1, and 3. Can I smooth that out? And you say, yes, look, I got this gap here. I can smooth that out. So this was the 5th edition of the book. Let's see what they did. They took 2. They used the 2 backhoes here. They moved these single backhoes over here, and this other one here, and then the 3 backhoes. So now look at what I did. I went from 2, 4, 1, 3 to 2s and 3s. So I start you out with 2, I ship you another backhoe, and you get the job done. Just by simply using up my slack and leveling resources. Now, version 5 actually had a little error here. If you look at this, They moved these two single backhoes, okay, and kept this double backhoe. Now, if they were all the same type of backhoes, maybe you juggle it, but look at this. This single backhoe up here is on the critical path. That, if I delay that one, I'm going to delay this task and this task. So I really want to keep these single backhoes, and I can delay this double backhoe. But see, they kept the double backhoe and moved the two singles. Version 6 of the book, the author fixed that and basically put the two here, backhoe 1's here, and the backhoe 2, move this backhoe 2 for the fence and walls over to here. So I'm still ended up with 2's and 3's, but I didn't impact my critical path up here. So you have to be careful that you're not moving the resources on your critical path. So, advantages of these leveling techniques: peak resources are reduced. We went from 1 to 4 to, or 2 to 4 to 1 to 3, and we leveled it 2's and 3's. Resources over the life of the project reduced. Fluctuation in resource demand is minimized. What did we lose? We lost some flexibility that occurs from reducing slack. Okay, so now it increases in the criticality of all tasks. Let's back up and look. So look at right here. By moving these backhoes over to here, okay, we took the double backhoes for the fence and walls and moved it. I now made that critical. Okay, I'm still got some slack up here in the irrigation, but I don't have any slack now in the fences and walls if I move this here. So I've now in effect added a critical path. So I've smoothed things out, but I've decreased my flexibility. Typically going to happen when you smooth things out. Now let's look at resource constraint and just introduce this, and then I'll do a couple examples in the next lecture. So for resource constraint, resources are limited, okay, in quantity or availability. So now the resources are limited. Again, usually we're talking people, humans, but it could be equipment. Activities are scheduled using heuristics, rules of thumb, that focus on keeping activities. So what activities do I keep? I'm going to keep the ones with minimum slack. Well, obviously 0 is minimum, so I want to keep the critical path ones. I'm not going to move those. Then, if everything has the same minimum slack, which can happen after a while, I'll keep the ones with the shortest duration. And eventually, if you get ties then too, you just kind of have a heuristic and you keep the ones with the lowest activity number. Okay, and we'll see how that goes. So it's an iterative process using these heuristics to now allocate resources. So let's look at an example. Here's a network, a simple network. Takes 9 days total. Okay, up here, remember we had early start, early finish, late start, late finish. This task is 2 days. The slack was in here at 4. And now in the middle, we've added how many bodies we need. So we need 5 people for task A, 5 for here, and so forth. So you can see those. So the ones with 0 slack are through here, so that's our critical path, B, C, F, and this is really just an ending point. They all end in 9. Okay, so B, C, F is our critical path. Okay, but if I look at this now and I add this up, look at this down here. I have 5 for A, and then A moves into E, and I need 5 here. Okay, and let's just say I haven't done any smoothing or anything yet. B needs 5 for a day, or whatever these are, let's call them days. C needs 10 and D needs 10. C goes for 2 days, D for 1. F goes for 6, needs 5 people. So look at where I'm at down here. If I just lay it out just in order, I need 10 people, 25, 15, 10s, and 5s. So I say, I can't give you that. I can't give you 25 there, or I can't even give you 15. I can give you 10 people. Now what are you going to do with the project? And is it going to impact the 9 days? Okay, so we're going to ask two things. What can I do to stretch this out so that I can level within the available resource constraint? I'm constrained to 10. And I'm asking, is that going to delay the project? It's going to add more risk because you're taking away slack. I get it. So let's look at this. There's several ways we can do this. Let's go look at these different ways. So first I could say I want to do tasks, and these are different heuristics. Okay, and then we'll go back to the one the book uses. You'll see that as one of the examples here. But other books, there's different heuristics, and you're going to just see they're all get you around the same answer. So we're going to do tasks as soon as possible. So I'm going to go back and forth here, sorry, but that's just the way to look at this. So I can do as soon as possible. I have 10 heads. Look, A's 5, B's 5. I can start both of those. So I'll start both of those. Okay, C could be started after B, okay, according to this, but I don't have enough heads, so I can't start it until here. That's as soon as possible. So I start C there, okay, then I can do D, then I can do E, then I can do F. Look at what we just did. By balancing to 10 heads, we took a 9-day project and made it 11 days. So boss, okay, I can do this with 10 heads, but I need 2 more days. One heuristic. Let's look at this heuristic, as late as possible. Okay, so let's go back again, sorry. A and E don't have to be done right away. They're not critical, they have some slack. So I'm going to hold them off, and I'm going to get started on B, C, D, and so forth. So here we are, B, D, C, and why did you do D before C? Because D was a shorter task, so I'm doing that first. You could have done either one, it wasn't going to affect this. Okay, then I come down and I do F. I could have started A here, but our rule is as late as possible. As late as possible, I do it this way. Either way, if I moved A and E back one, F is still the limiter. But look at this. By doing this heuristic, I now just saved a day, and I can get this task done in 10 days instead of 9. Still a delay, but only 1 day. Let's look at another heuristic. Most resources. I want to do the things with most resources first. I'm not going to bounce back, but A and B were both 5s, and I can do them, so I get them started. C and D were 10s. I do those next. A, E, and F were 5s. Do those next. This heuristic for this simple case gives us the same as up here, 11 days. I could do the shortest task times first, do all the shortest ones first. B, A, those are the shortest. B was, so I did that. Then I switched C and D. I did D first. E and F, still 11 days. Or minimum least slack. So which things had the least slack? I'll do those first. Okay, so I can start A and B. Okay, C, E, F, and D, and if you went back and looked at that, you would see that. So 11 days. So each of those are different heuristics, balancing out the 10 heads I gave you and seeing what it does. and the best answer was, I'm delaying 1 day. Next lecture, we'll talk a little bit about Microsoft Project and loading resources. And you'll see Microsoft Project does this quite handily for us. And in this particular example, I'll show you Microsoft Project will give us 10 days. It goes through internal heuristics, and it does this for us and will give us the 10 days when we're all done.